Right now, one country is building projects so massive, they make the rest of the world look years behind. This is not about one headline or one lucky success story. This is about a national pattern of relentless construction.
While others debate budgets and delays, these projects are already under construction, already moving, already changing the map. The real shock is not the size of any single project, but the fact that so many are happening at the same time.
What you are about to see is engineering used like a declaration of national intent. From the Himalayas to the sea, each location reveals a different version of the same message. Build bigger, build faster, build farther.
This is where design, data, machinery, and political will combine into something the modern world rarely sees at full power.
These projects are not future concepts. They are real, physical, operating examples of ambition already turned into concrete and steel.
And by the end of this journey, you will understand why so many engineers are watching China with a mix of admiration, disbelief, and urgency.
Deep in Tibet, one river falls with a force so rare that engineers saw in it the blueprint for the project of a century.
In just a short stretch, this river plunges almost 2,000 meters, creating one of the most concentrated energy opportunities on Earth.
Yet China chose to build not one structure, but a linked system designed to capture every possible unit of hydropower. This is infrastructure at the edge of what engineering can physically attempt, executed with the confidence of a nation thinking decades ahead.
When completed, its power output is expected to dwarf even the world-famous Three Gorges Dam.
The purpose is simple but immense. Convert a remote river into clean energy for hundreds of millions of people.
It is the kind of project most countries would treat as science fiction, but here it is being approached as a national milestone. And this is only the beginning, because China's appetite for the impossible does not stop at rivers, it extends straight into the sky.
In southern China, the landscape opens into a canyon so deep that the river below looks more like a line than a body of water.
At 625 meters, this drop is taller than some of the world's most famous landmarks.
Most engineers would call this gap a warning, but China treated it as an opportunity. Precision mattered here, at a scale where traditional methods would have struggled to function.
Every meter of this crossing had to be assembled where gravity itself felt like part of the opposition. What once took 4 exhausting hours can now be crossed in just 4 minutes. This is more than a bridge. It is a total rewrite of movement, trade, and daily life for the region around it.
People come here not just to cross it, but to witness what happens when ambition meets pure vertical space.
And if building over a canyon felt extreme, the next project pushes even farther into open ocean. The sea is a moving battlefield of logistics, weather, and shipping pressure, and this is where the next mega project rises. This is not a normal bridge over calm water. It is a strategic sea crossing through one of Asia's busiest maritime corridors.
To keep shipping lanes open, part of the route does something extraordinary. It disappears beneath the sea.
Before the tunnel could even begin, engineers had to create solid ground where none existed. The entire system was built to survive typhoons, earthquakes, and impacts powerful enough to destroy ordinary infrastructure.
At this scale, the crossing stops feeling like a road and starts feeling like a statement.
What used to be a long regional journey becomes a fast, seamless connection across open water.
This project does not simply connect places. It reorganizes how an entire economic region breathes.
But for all its elegance over the ocean, the next challenge lies in mountains actively trying to resist human access. There are landscapes that seem to tell humanity to stay out, and the route to Tibet is one of them. This railway crosses active faults, unstable slopes, freezing passes, and terrain where even machines struggle to survive. In some sections, the underground temperature climbs close to boiling, turning tunnel work into a test of endurance and engineering.
To force a rail line through this route, China had to combine bridges, tunnels, and custom machinery on a near unprecedented scale.
What others judged technically impossible for decades is now being treated as a long, difficult, but achievable corridor. When complete, this railway will shrink distances that once separated communities for days.
This is not just transport infrastructure. It is a refusal to let geography dictate the limits of connection.
And if building through this terrain sounds impossible, wait until you see what China chose to do in an earthquake zone with a dam. In Sichuan, China set out to build a dam so tall it would break the global record in one of the worst places to take that risk. And the challenge is not just height, it is the fact that this entire region is known for destructive seismic activity. Instead of fighting the Earth with rigidity alone, engineers built a design meant to absorb stress and survive violent movement. Every layer, every angle, every material choice had to answer one question. How do you hold back a river when the ground itself may shake?
Now the reservoir is forming, and the project is shifting from construction challenge to operational reality.
Once fully active, the dam will feed clean electricity into the grid at a scale that touches millions of homes. From raw function, the story now shifts towards something equally revealing: infrastructure designed to be beautiful as well as enormous.
When the design for this airport first appeared, many thought it looked too futuristic to ever be built.
But China built it, and the result is one of the most distinctive transport structures on Earth.
The scale is immense, yet the design feels organic, almost like a structure grown instead of assembled. This single terminal spans a footprint so large, it redefines what one airport building can be. The genius of the design is not just visual impact, it is efficiency, bringing every gate closer to the traveler. Beauty here works together with logistics, turning heavy passenger movement into something smoother and more intuitive. This airport proves that infrastructure does not have to choose between utility and spectacle.
It represents a philosophy where design itself becomes part of national confidence.
And if one building can embody the future, the next project asks an even bigger question. What if an entire city could be designed from scratch? Most cities grow by accident, but Xiongan is being built by design. Before streets were laid down, algorithms were already testing how millions of people would live, move, and work here.
Every road, utility line, park, and transit stop was conceived as part of one complete system.
Even the invisible parts of the city were planned to reduce disruption, keeping essential systems below ground and easy to maintain.
What appears on the surface is an urban environment designed to feel cleaner, quieter, and more intentional. Transit here is imagined as a living network that adapts to human movement instead of forcing people to adapt to it. The promise is simple. Essential services should be close, accessible, and woven directly into daily life. This is not only a smart city, it is an attempt to make density, technology, and green space work together.
Shyong asks a powerful question. If we know what makes older cities inefficient, why keep repeating the same mistakes? Then there is a project that points not toward roads or power, but toward the deepest silence of the universe. Fast is so large that ordinary comparisons fail, because from above it feels less like a machine and more like a man-made landform.
At 500 meters across, this instrument occupies a category almost entirely its own. Its purpose is not to shout into space, but to listen with unprecedented sensitivity. Signals that began their journey before human civilization can now be gathered by one of the most powerful scientific ears ever built. FAST has already expanded our understanding of pulsars and the structure of the cosmos. But what captures the imagination most is the possibility that if something else is out there, this is one of humanity's best chances to hear it.
the project turns a remote valley into a listening post for the universe itself.
From cosmic listening, the story now returns to Earth with something equally astonishing: a train moving at speeds that challenge our idea of ground travel.
Most people associate extreme speed with aircraft, but China is pushing that sensation onto rails.
In testing, the CR450 has reached speeds that place land travel into an entirely new conversation.
This is the moment where a train stops feeling conventional and starts feeling like a controlled ground rocket.
What matters is not only top speed, but what that speed means when connected to the world's largest high-speed rail network.
Journeys that once demanded long hours begin to compress into timeframes that change business, mobility, and personal life.
The achievement is not brute velocity alone, but speed delivered with stability, precision, and practical usability.
The train is impressive, but the larger story is a country building an integrated system at continental scale. This is how technology becomes transformative, not as an isolated prototype, but as part of a living national network.
And the last project proves that even in a world obsessed with speed, control over geography may be the more powerful advantage. At first glance, a canal may sound less dramatic than a bridge or a dam, but this project may be one of the most strategic of them all.
The Pinglu Canal is not being dug through easy flat land, it is being forced through difficult ground to create a new maritime path.
For more than a century, the world saw almost no new canal projects of this magnitude, and now China is changing that.
Before this corridor, the region lacked direct sea access, adding time and cost to everything moving in and out.
With one canal, an entire region gains a shorter, more competitive connection to global trade.
This is a quieter kind of mega project, not flashy on the surface, but enormously powerful in economic effect. And that is the larger point. None of these achievements stands alone. Together, they reveal a national construction machine operating at extraordinary range.
When you step back, the true story is not a list of projects, but a widening gap between those who plan and those who execute.
This is why the world is paying attention, because when ambition, scale, and execution move together, the future stops being predicted and starts being built.